Okay, I've changed it over now to Series Bridge Rectifiers, so I've connected them to the slip ring and onto the NEMA 17. So I'm ready now to insert this slot in there and put the cover on. I inserted these, they use them in 3D printing, these little insert sockets, these things here. Even though these are not great, they're the cheapest of the lot. I prefer the ones that have got some sort of knurling across for better grip. They're not a great grip, but they'll do for Okay, I have it boxed up now. It's a lot neater than the original setup. And this is shorter than this, so it's not sticking out too far. Okay, there is a bit of weight. There's a bit more weight overhang than what there was, but I can't do anything about that. But it's not that heavy. I drilled a little hole in the bottom just for ventilation and if any water or moisture gets in and drain off. So the next thing now will be to test it. Okay, I've just done a test now at 400 and 1400 RPM. Via a DC to DC buck converter. The results I got was at 400 RPM, not coming up above the battery voltage, so no results. At 1400 RPM, over two tests, basically 12.85 watts, about 400 milliamps, 5 to 5.1 watts, and that really is max. My understanding is max with the NEMA 17 stepper motor, because I'm now really talking about one phase. When I was parallel I was getting up to about 7.5 watts max. So this is the compromise, 400 milliamps max. Okay, this test again is direct to the battery, and what I got was 400 RPM. Again, nothing won't come up against above the battery voltage at 400 RPM. Of course, I don't know what the voltage was. I think it was going up, but I'm getting 406 milliamps, which is basically the same as if I'm going through the buck converter. The reason I want to try the buck converter is I'm afraid that the voltage could peak above this solar charge controller, and I might have to fit. I have a small DC to DC buck converter that I might install in here and set at maybe 20 volts. These are usually for solar panels which can go to 21, 22 volts. I don't want to potentially bang in 40, 44, 45 volts into it. So that's it really. The max I can get would be about 400 milliamps as I thought. I was hoping a bit more, but 400 milliamps. The 400 RPM is just below the battery voltage. So if my battery was below, say it was down at 12 volts, she would put in a bit. But it doesn't take much above 400 RPM to start producing a bit of current, so it's going to really be down to testing it with real wind conditions and see what I get. Okay, we're getting a bit now. She seems to cut in about 10 miles per hour, but she's more regular now. I will be waiting a longer time with the series, so at least I'm getting something into it. I'm now charging a deep cycle battery. And it's I have the fridge on drawing a load from her, which would be a situation where I would need a bit of wind. This is what we're getting now, and I've been noticing that now she at 14 knots of wind she'll produce the 400 milliamps. She'll start producing a few milliamps when she reaches 10 knots. Those wind readings, of course, are coming from the top of the mast, which is a lot higher than we are. We're only about a third of that height. There we are now. Yeah, she about 5 watts, 420 milliamps. That's her max. She's certainly producing a lot more than this cutting edge Cyclone so-called 33 watts was supposed to produce. Could get nothing out of it. At least now with this NEMA 17 stepper motor I'm actually getting juice. My journey to get up to 1 ampere hour charging, that's still ongoing. The trouble is, if I go for bigger, say a NEMA 23, everything gets a bit heavier and the blade diameters get bigger.